Hi, in my previous video, we have solved question 1 to question 5 of the CBSE Board 2023 math paper, grade 10. In today's video, we will be solving question number 6 to question number 10. So question 6 says, the curved surface area of a cone having height 24 centimeter and radius 7 centimeter. This is a very straightforward question. We know the formula for the curved surface of the cone. The curved surface area of the cone is given by pi, r and L, where L is the slant height. If this is our cone, this is the radius, this is the height of the cone, and this is the slant height of the cone. The height is given as 24 centimeter, radius is given as 7 centimeter. So the first thing is to find the slant height. We'll apply Pythagoras theorem here and I'll get 24 square plus 7 square as L square, which gives me 625. So L is equal to square root of 625, which is 25. So my slant height is L, which is 25. And now pi r L will be equal to 22 by 7. If nothing is mentioned about the value of pi, we will take it as 22 by 7. The radius is 7 and the height is slant height is 25. This cancels off to give us 11 times 50, which is nothing but 550 centimeters square, and our answer is choice C. Okay, clear? Let's move on to question number 7. The endpoints of the diameter of a circle are given as 2, 4 and -3, -1, and we need to find the radius of the circle. This is a very easy question again. Circle. This is the diameter. Diameter is the chord that passes through the center of the circle. One end point of the diameter is 2, 4. The other end point is -3, -1. And we have to find the radius. Okay, so how we can do it? We know that radius is nothing but half of the diameter d. Correct? So let us find the length of the diameter d. The length is given by the formula x2 minus x1 whole square plus y2 minus y1 whole square. This is the length between the 2 points x1 y1 and x2 y2. If we apply this formula, then we will get the diameter as -3 minus 4 whole square plus -1. It's -3 minus 2 whole square, x2 minus x1 whole square plus y2 minus y1 whole square, which gives us a square root of -5 whole square plus -5 whole square, correct? Which gives me square root of 50 as the diameter. So 50 can be simplified as 25 times 2. Square root of 25 is 5. So diameter is 5 root 2 and radius will be half of 5 root 2. Correct? Which is 5 by 2 root 2. And again the answer is choice C. Is it very clear? Let's move on to question number 8 now. Which of the following quadratic polynomials have the zeros 5 by 3 and 0? If we have to find the zeros, we have to equate the quadratic polynomial to 0. So let us pick choice A and equate that to 0. If we have to find the zeros is that value of x which makes your polynomial equal to 0. So from here, when is the product of the factors 0? When either x is 0 or 3x minus 5 is 0. Am I right? So from here we get x is equal to 5 over 3 and here x is 0 and hence the two zeros are 0 and 5 by 3. So our choice A is the correct answer. Correct? If we look at choice B, it is 3x times x minus 5. When is this product equals to 0? When x is 0 and when x minus 5 is 0. So x is 5. This is not satisfying our condition for the zeros given. Correct. Similarly, if we take x square minus 5 by 3 equals to 0, it is x square is equal to 5 by 3, or x is equal to plus or minus square root of 5 by 3, which again doesn't match our criteria. And the last one, if we take 5 by 3, x square is equal to 0. This is possible only when x is 0. So here also both the 0 criterias are not matching, hence the correct choice is choice A. I hope this question is very clear. Okay, now let us move quickly to question number 9. The graph of y is equal to px is given for a polynomial px. This is the graph given. The number of zeros of the px. Now what are the zeros when we look at the graph? Zeros are the points where the graph cuts or touches the x-axis, because when it touches or crosses the x-axis, the y coordinate of that point becomes 0. Correct? And that's why that particular x value is known as the 0. So here we see that the graph of p of x is actually touching the x-axis only once, and hence it has got only one root. Basically, a quadratic equation always have two roots. So in this case, there are two real and repeated or equal roots. Since the roots are equal, we say that this particular graph has got 1, 0. The term zeros and roots are used interchangeably. So here the answer is 1, 0. If our graph given is like this, then in this case the graph is cutting the x-axis at 2 points. These are the two places where the value of the polynomial becomes 0. So these two x values will be your two zeros of this polynomial. Is that clear? And if your graph is like this, the graph will never cut the x-axis. Hence there are no real zeros or no zeros at all. Okay, so I hope this question is clear, that this particular graph has got exactly 1, 0. Let's go ahead to question number 10, the last question of this video. Of k for which the given pair of equation has infinitely many solutions. Before solving the question, let us see that if we have the standard form of a linear equation as a1x plus b1y plus c1 equals to 0, and there is another linear equation a2x plus b2y plus c2 equals to 0, what is the condition when they have infinitely many solutions? Infinitely many solution means the lines are coincident, and that is possible when the ratio of a1, a2, ratio of b1, b2 and the ratio of c1, c2, the coefficients of x, y and the constant terms ratio are all same. This is the condition for the two linear equations to be coincident or have infinitely many solutions. Okay, so in our case, first let us bring all the terms to one side. So kx is equal to y plus 2. So I'll write the equation as kx minus y minus 2 equals to 0. Okay, I will write a1x plus b1y plus c1 equals to 0 and get the value of a1 as k, b1 as negative 1 and c1 as negative 2. Fine. Now let us take the other equation. 6x is equal to 2y plus 3. So bring all the terms to the left hand side and you get this equation, and this is a2x plus b2y plus c2 equals to 0. So what are the values of a2? a2 is 6, b2 is negative 2 and c2 is negative 3. So now let us find out b1 over b2. b1 over b2 is minus 1 over minus 2, which is 1 over 2. And c1 over c2 is minus 2 over minus 3, which is 2 over 3. So the first thing is that b1 over b2 only is not equal to c1 over c2. This condition is not satisfied at all. And this means that there exists no value of k for which this particular equation will have infinite solution, because b1 over b2 is not equal to c1 over c2. Okay, so the answer is does not exist. If you have any doubts regarding these questions, you can send me an email at kirti.mathacademy@gmail.com. This is my YouTube channel Mathacademy. If you have liked my videos, please don't forget to like, share and subscribe. Thank you.